Okay, so we're back with adding and subtracting rational expressions with different denominators. So we've got a denominator of z plus 6 on this rational expression and a denominator of z minus 1 over here on this rational expression. So this example is definitely different than the previous example where one of the denominators was y and the other one was negative y. That was pretty easy to see exactly how we could make those denominators match. But in this case, there's nothing I can multiply z plus 6 by to make it look exactly like z minus 1. And there's nothing I can multiply z minus 1 by to make it look like z plus 6. So instead, we're going to have to make an entirely new denominator that we're going to change both of these denominators into. So when you can't change one denominator into the other or vice versa, you have to create an entirely new denominator to do that. And that's where your least common denominator is going to come into play. So we're going to find that LCM of the denominators, and I'm going to write that out one time, and from now on I'm going to refer to that as the LCD. All these acronyms. Okay, so we're thinking the least common multiple, right, of the denominators. So I look at z plus 6, and you think about z plus 6 factored form. And at this point, hopefully after our 5.1 and all of our module 4, we're comfortable with saying, well, z plus 6 in factored form is just simply z plus 6. It doesn't get any more factored than that. So it simply is a factor of z plus 6, and you can even put it in parentheses if it makes you more comfortable, and you can even write out a positive 1 out in front of it, right? So if you got to make it look like a product, there it is. It's 1 times the quantity of z plus 6, or just z plus 6. And the same thing's going to happen with z minus 1, because it is a binomial and they don't share any common factors other than the number 1. So simply 1 factor of z minus 1 there. So if we go back to how do we find the LCM, so remember we take the observed factors in either factored form. So I see a factor of z plus 6, and it occurs at most 1 time. So I record it 1 time. And then I see a factor of z minus 1 in the other factored form, and you could call it its prime factorization if you wanted to. We usually keep that phrase reserved for numbers, but in its completely factored form, there's 1 factor of z minus 1. So we include 1 factor of z minus 1 in the LCM. So this is going to be our new denominator. So this is the denominator we want to create in our rational expression. So we want a z plus 6 times a z minus 1. Okay, so this is where we've got to do a little bit of work to our original problem. So our original problem is z minus 9 over z plus 6. So I'm just going to record it down here. And again, we're adding, and I'm going to leave myself a little space, and there's a reason for that, a z plus 4 over z minus 1. So we found that least common denominator. Now remember, the second step said we have to multiply by a convenient 1 to make our denominators match that LCD. And we do that with the missing factors. So if you notice, this denominator already has a factor of z plus 6. So it's got this, you'd be like, oh, check, that has a factor of z plus 6. But what it doesn't have is a factor of z minus 1. So I'm going to make it have a factor of z minus 1 by multiplying by z minus 1. So I'm going to create that product down below. Now we do call it a convenient 1 because if we multiply with it on the bottom of that fraction, we also have to multiply with it on the top of the fraction. So if you notice, this rational expression's denominator now looks like our least common multiple of our denominators, which we call, again, our LCD. So now I'll go over here. I've got a factor of z minus 1 in this denominator, so check. But what's missing is that z plus 6. So I'm going to multiply by that missing z plus 6 factor to make it have that, to make it match that LCD. And again, I multiplied with it on the bottom, so I'm also going to have to multiply with it on the top as well. We're creating that convenient 1. So if I were to divide, right, that's that common factor, so that has a value of 1, common factor that has a value of 1. So I'm not changed the value here at all. I am creating still equivalent expressions, meaning they have the same value, they just have a different form. So if you notice now, what this becomes is we've got some module 3 multiplying binomials in there, and we will also then, once we've gotten from there, we will have our adding. So we've got some old skills mixed with those new skills. So I'm going to leave the denominators right now in their what we would call factored form. And I'm just going to address the numerators. But if you notice, I now have the same denominator. I know those factors are in different orders, but it is the same factor. So if I'm multiplying z minus 9 times z minus 1, I get a z squared minus z minus 9z plus 9. And then when I do my multiplication in the numerator of my second rational expression, I do need to put parentheses around that to be a little bit more clear. Z squared, 6z, 4z, and then I get a 24. Spin that out. Okay, and so now it's just adding with like denominators. So I record my denominator, and you just get to choose, you know, you're going to say z plus 6, you're going to say z minus 1 at this point. And again, I will deal with that at the very end. I like to get my numerator situated and they'll get my denominator situated. So I've got z squared minus 10z plus 9 from the first numerator plus z squared plus 10z plus 24 from my second denominator. And if you notice, I simply simplified those middle terms in the next step. So we just have to do our simplifying at this point in that numerator. So that's going to be a 2z squared. I have opposites here, negative 10z and positive 10z, so that has a value of 0, so there's not going to be a z term. And then 9 and 24 gives us 33. And now I can address that denominator. So that's going to be a z squared minus z plus 6z minus 6 to z squared plus 33 in the top, and then that denominator will simplify to a z squared plus 5z minus 6. And if you were concerned about simplifying we would be checking right here at this point the 2z squared plus 33. 2 and 33 don't share any common factors, so that is the simplified form there. So we're not going to see any common factors between the numerator and that denominator. So there's the factors of the denominator. This numerator does not factor over our integers. So these problems, when you are adding or subtracting with unlike denominators, it's just going to take a little bit longer. But the big point here, just like in the example before, is we want to make those denominators match. So the example before with the y and negative y, we only had to change one denominator because we could actually make it match the second, the other denominator. But in this case, we couldn't change this denominator into this one or this denominator into this one. So we had to create an entirely new denominator, which we called the LCD there. So sometimes you do have to create an entirely new denominator in order to proceed. So once you have your denominators matching, then you simply finish out the problem using those techniques of the denominator of that sum will be your like denominator, and then you're just adding those two numerators. Or if we're subtracting, then we would subtract those two numerators. So that video got a little bit long. We'll see two more examples of this.